This video is about applying your knowledge of trigonometry to solve questions of this nature. So the knowledge you have of trig ratio, laws of sine and cosine, and elevation and depression, you'll be combining all that knowledge to solve this question or question of this nature. Okay, so let's get into it. From a plane flying due east at 265 meters above sea level, the angles of depression of two ships sailing due east measure 35 degrees and 25 degrees. How far apart are the ships? Now I'm going to draw my cardinal point here. So this is north, this is south, and west and east always spell we. Okay? Alright, so I want you to pay attention that these are all 90 degrees here. Alright, good. So let's draw our diagram. Always use that diagram to represent your word problems. Alright, so it says from a plane flying due east at 265 meters above sea level. So this would be your 265 degrees above sea level. So let me write that here, 265 meters above sea level. The plane is flying due east. So the plane is here. Here is the sea. Here is the plane. So the plane is going to fly due east. Okay? The fact that it's an angle of depression, then we need to represent the horizontal. So this is the horizontal of the observer. So the observer observes two ships. Okay? So one ship is here. Another ship is here. Alright? And this is the sea. Alright? So this is your diagram here. Now, this observer observed these two ships at two different angles. Now, one angle here, this would be the smaller angle. This is 25 degrees. And look at your alternate angle. So it means that right here would be 25 degrees as well. And then you have your overall angle here. From here, still from your horizontal to your line of sight, this is your new line of sight. Okay, so this entire distance here would be 35. So this would be 35 degrees, which would be the same as this part here, 35 degrees. Now, if you're not sure about it, just know that the further you are away from the 90 degrees, so let's put our 90 here. So this is our 90 here. The further you are away from the 90 degrees, the smaller the angle will be. The closer you come to the 90, the larger the angle is getting. Okay, so that is why we know the 25 should be here because it's further away from the 90, and the 35 should be here because it's closer to the 90. Okay, alright, so we could draw another diagram just so we are clear as to what we're doing. So this is our final diagram here. Okay, so this is 35 degrees, this is 25 degrees, this is our 90, and this is 265 meters. Now they're asking us how far apart are the ships. So one ship is here, another ship is here, so they want this distance. So let's call this distance x. Okay, now we're going to apply some laws. So let's look at this thing here. We're going to keep this thing above here just as reference. So this is our diagram. Now, there are several ways we can approach this thing. For one, we can use the entire diagram. So if I'm looking at the outer triangle, the large triangle, it would be this side and this angle, because this angle here is for the entire triangle. So I could use that to find the hypotenuse, the overall hypotenuse of the triangle. Okay, so let's do that. So if I label my diagram here, the side across from my 90, this would be my hypotenuse. Okay, this is my including angle, so this part here would be my opposite. Okay, and again, if I go back to my SOHCAHTOA, this part that we get is opposite, and this side that we want to find in this case is our hypotenuse. So realize that sine is the one that has O and H in it. Okay, so let's do that. Let's find that thing. So we would say sine of the angle which is 25 degrees equal opposite, which is 265, divided by hypotenuse, and we're going to call this part here x. Okay? So again, we want to get rid of the x on the denominator, so we're going to multiply both sides by x. So I multiply this by x, and I multiply that by x there. Okay? So the x in the denominator would be cancelled by this one here. So what I have is x sine 25 degrees, and that equals to 265. Sine 25 is a number, so I divide both sides by sine 25. Okay, and that cancels there. So x equal, let's put this in the calculator. So make sure your calculator is in degrees. So this is parentheses 265 parentheses divided by sine 25, and that would give us 627. I'm going to keep it to the nearest whole. 627 meters. That would be this length. So this entire length here is 627 meters. Okay? Now that we have this length, I can draw another triangle. Watch this. If I know this angle here, I know this one. Because angles at a point on a straight line are supplementary. So it means that, let me draw this thing a little bit bigger. It means that if I have, this is my diagram. I have my 25 here. If I have this is my 35. This 35 and this angle here must give me 180. Angle at a point on a straight line supplementary. So this 35 along with this angle here must give me 180. So I can subtract. So I have my 180 minus my 35 here, and that would give me my other angle, which is 145. So I know this is 145 degrees. Now I know this, and I know this side. We just found this side here, which is 627 meters. Okay? So now I can take off this triangle here. And when I take off this triangle, this part would be the same as right here that we want to find. Okay, so I'll still have my 25 here, which is this. I'll have my 625 here, which is this. But this angle here would be this one now. So I'm going to take off this triangle just to make my work easier. Okay, so let's take off that triangle. I'm looking at this now. This is my new diagram that I'm dealing with. This would be 145 degrees. This part is 627 meters. This angle here is 25 degrees. Alright, and we want to find this part here, so we're going to call this part here x. Now remember that the sine law says that you will have maybe all three angles on a side and ask to find any of the other side. And remember, if you have two angles, automatically you have all three angles. So I could subtract, I could add these two and subtract it from 180 to find this one. So let's do that. So I'll have my 180 minus 145 plus 25, and that would give me 10. Okay, so I know that this is 10 degrees right there. Okay, now this would give me the law of sine. How I know that it's the law of sine? The law of sine says that if we have all three angles of the triangle and any one of the sides, then we can find any of the other two sides. And the law of sine always gives us a reference. The reference is when you have an angle and a side facing it. And then you have another angle and I have to find the side facing it. Okay? So that's one instance. So this is my reference. Okay? So that would just be the side divided by sine of the angle. So the sine is 625. So this 627 I mean. So this would be 627 divided by sine of the angle facing it, which is 145, equals, I want to find this side, and I call this side x, so it would be x divided by sine of the angle facing this side, which is 10. That is why we needed to find that angle there. Okay, Now we could cross multiply, we multiply diagonally, okay? So it would be 627 sine 10, so this side times this equals x sine 145. This side times that, okay? Now I want my x by itself. Again, I can divide both sides by sine 145. So this part would cancel. I have my x now by itself. So I can put all of this in my calculator now. So let's do that. So this parentheses 627 sine 10 divided by sine 145. And that would give us 189.8. Okay, so that would be to the nearest tenth, or to the nearest whole, I would put that as 190. Okay, so this would be 190 meters equal x. So therefore, and remember that x, if we come back to our original diagram, x was the distance between both ships. So we could say therefore distance between both ships equal 190 meters. Okay, and this would be your final thing here. Alright, I hope this is a little bit more practical as to how you apply the different laws in trigonometry in solving a question. Have a great day.